Hey, Mr. J coming at you with another probability video. This one we're going to look at sort of likelihood. So like when you're doing a little experiment, a probability game or experiment, what's your chance, what's your likelihood of getting either what you want or a specific result, okay? So, you know, when we start teaching probability to the younger grades, we're really looking at those probability words, okay? But basically, I mean, not basically, exactly, probabilities exist in a number, okay? They're always between 0 and 1. Even the words, you know, are sort of in there. So let's put some things in here, okay? Let's put some things in here. So for example, in the middle here, all right, I could put that as half. I could also put that as a decimal, 0 and 5/10, 0.5, okay? That's sort of something that is, well, let's put the word in. That's equally likely, okay? And that would be something like flipping a coin, all right? So if I get my fancy coin out, my chance of getting heads is one of those things. Okay, we could also represent it as a percent, which is definitely not grade 4 or 5, but let's put it in there anyways, okay? So those are sort of the different, you know, numbers or words or decimals or fractions or percentages. Those are different ways that I could represent my chance of getting heads with a coin, okay? And my chance of getting tails is the same. It's 50-50, it's 0.5, it's 5/10, it's half, it's equally likely. Whatever term I want to use, that's where it is, okay? The numbers are great because they're very precise. So the 50%, the 0 and 5/10, or 0.5, the half, those are all like very sort of precise words, numbers. They're exact, okay? If I take my dice as a different example instead of the coin, I can still have a half chance, 0.5, 0 and 5/10, I should say, a 50% and equally likely. I could still come up with an experiment where I get that outcome, okay, or that likelihood, that probability. For example, I could say, you know, my chance, I shouldn't use the word chance, I should say the probability or the likelihood of rolling, and then I could pick. So I could say a 1, 3, or 6. Or I could say an even number. Or I could say odd, okay? So I try to think of something where I have 3 outcomes, okay? And that would still fit that, but more reasonably, I could instead use a different fraction. So instead of 1 out of 2, 1/2, I could say 3 out of 6. And in my opinion, that's a better fraction to represent, let's say, an even number, okay? Because what are my outcomes if I roll this dice? I could get a 1, I could get a 2, I could get a 3, a 4, a 5, or 6, okay? This is just a regular dice, there's no funny business. So if I'm looking for even numbers, I got 1 option, 2 options, or 3 options, okay? So there are 3 ways that I could get my even number out of, and that's always a good way to refer to that line in a fraction. So 3 out of 1, 2, 3, 4, 5, 6 outcomes, okay? So as you can see, just at one exact point on this number line, there are a number of ways I could refer to this outcome, okay? There's a probability of this outcome, I should say. It's 50%, 0 and 5/10, half, equally likely, 3/6, or if I use something different, then maybe it's not 3 out of 6. Maybe it's, you know, 5 million out of 10 million or something crazy like that. But it's always going to be right there on that number line, okay? Okay, now let's put another one. Let's split that like that. So now this becomes 1 part, 2 part, 3 parts, 4 parts, right? And this would be 3 out of 4. This becomes 2 out of 4. And this would be like 1 out of 4, okay? And I don't really have a good example for that out of any of my choices here. I don't have any like 4-sided die or anything. Oh, that would be pretty cool actually. Or like a spinner, but let's imagine something that looks like that. So let's take this imaginary spinner and imagine that I was good at drawing and I drew those all equal size, okay? And let's put in green and blue, and this pen rules, man. What an invention. I hope whoever invented this got the Nobel Prize for coming up with a pen with all these different colors. Okay, so now it's got 4 different colors. So if I was going to say, what's the probability or what's the likelihood of getting green? Okay, and I would represent that on my number line right there, 1 out of 4, because there are 1, 2, 3, 4 possible outcomes and I said I want to find green. Well, that's only one out of the 4 outcomes, right? In other words, 3 out of the 4 outcomes, right, blue, black, and red, are the outcomes I'm not interested in for this experiment or game or whatever it is I'm doing, okay? So that would exist right there, 1 out of 4. Now, the reason I like the fractions or decimals or percentages the best is because they're precise. I know exactly where that is on the number line, right? I could, get out my ruler or my grid paper and make like a perfect, well, let's do it. I can make a perfect number line from 0 to 4, and I could mark those points. Okay, and then I could say this is exactly, maybe not exactly, but that is the point where I can get the likelihood of getting green is exactly there, okay? 1 out of 4, and I've measured it, looks perfect. Beauty, okay? Versus the words, okay? The reason we start with the words with little kids is because they're easier to understand, they're easier to write, maybe they don't understand fractions yet. But here, I would use the term less likely, okay? That's like the mathematically agreed upon term of that. Now, my problem with that, and as you get older, you want to be a little more precise. The problem is that, so there's my 1 out of 4. The problem is that this is also less likely, and this is less likely, and this is less likely, and even that is less likely, and that's less likely. Okay? So having a more precise way to represent our probabilities, for example, in a fraction, is a lot better than having just these words. Because this might be, something that's almost 0. And remember, 0 is impossible. Oh, I should have got more room. So 0 is impossible. So that's like, for example, rolling a 7 on this dice. Okay, it cannot, it's impossible. It can't happen, right? And this little dot that's just slightly more than impossible might be something like, seeing a planet explode. Okay, now, I've never seen a planet explode. Chances are you've probably never seen a planet explode unless you've got a more interesting life than I know. I don't know anyone who's seen a planet explode, okay? But I do know the planets probably do explode. It's a big universe. There's billions upon billions of planets out there. There's been planets that have exploded, okay? So it's possible you could see. It's, it's less likely, but it's still possible, okay? So that's why I put it right there on my probability number line. It's almost impossible, but it's still possible. Well, it gets the term less likely, whereas something that's 1 out of 4 also gets the term less likely. And something that would be right there would also get the term less likely. Okay? So for me, in my opinion, it's too much of an area to cover, right? Impossible is just right there. It's only 0, nothing bigger, and there's no such thing as smaller on this probability scale. So impossible gets a tiny dot. Equally likely gets a tiny dot. Certain gets a tiny dot. And then less likely gets all this area. Okay, weird. Okay, and then all of this area gets the term, more likely. But again, some things are more likely than others, right? So more likely that I'll see a bird if I walk along a nature trail. Because, every time I walk along a nature trail for, half an hour, let's say, I see several birds, right? I might see 20 birds or 50 birds or at least 10 birds, but it's possible I might see no birds. It's not certain I will see a bird, but it's very, very, very more likely. And I would maybe give that a fraction as maybe even something like 999 out of 1,000 times that I go on a half an hour walk on a nature trail, I see at least one bird, right? It's almost certain, but it could happen that I don't, right? Whereas also a probability that's there on this probability scale also gets the term more likely, just because it's a little more than half, okay? So that's why as we get older, or as you get older, we want you to use something else besides those terms, okay? And the best way is those fractions, because they're actually the easiest way. So let's do a couple. We already did a couple, but let's do a couple more. Let's do the dice first, okay? So there's my dice. It's a normal dice. It has 6 outcomes, right? I could get a 1, 2, 3, 4, 5, 6. So I say, what is the probability? And at this point, we're talking math, right? So we're not going to do the experiment. We're just thinking about the experiment. So if I was to roll the dice, so I'm getting a right chance again. I shouldn't. Probability of getting let's go with 3. Okay, so probability of getting a 3. And so I look at it. I say, I want to represent this as a fraction because I'm getting older. And so I say, well, here's the outcomes. There's 6 of them. So that becomes your denominator, okay? Your out of number. Out of 6, because 6 represents the number of possible outcomes. Okay, so there are 6 things that could happen when I roll this dice, right? I could get a 1, 2, 3, 4, 5, 6. That's it. There's no other options, and none of them is more likely than the other. Okay, so this is like a fair dice. It's equally cut or whatever. It's fair. Okay, if I had some weird spinner, you know, where the spacing wasn't like equal. Let's say it's like a really wonky spinner where there's like, you know, this really big space here and these really tight spaces here. Well, then you need to do a lot more math to figure out how many outcomes you have. Because you can't just say, well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 outcomes and say it's out of 10. I mean, that's not really accurate. There are 10 things that could happen. That's true. But this one is a lot more likely to happen than this one. Okay, so you have to consider that when you're doing these probability things as well. But, you know, in grade 4 and 5, we're going to use fair things. So it's a fair dice. There are 6 equal possible outcomes, we could say. Okay, and now we're looking for 3, probability of getting a 3. Well, that's only one of my outcomes. Okay, so it becomes a 1 out of 6 if I was going to represent this as a fraction, because there is one outcome I'm looking for. And the outcome is rolling a 3. Okay? So some kids, a common mistake you see is they put a 3 out of 6. Because they say, well, I want to get a 3 and there's 6 things I could get. Yeah, you want to get a 3, that's true, the number 3, but it's not the number that you put here, it's the number of outcomes. Okay? And so I should really say that, I guess. Number of outcomes I'm looking for. And there's only one that I'm looking for, which is a 3 out of 6 total possible equal outcomes. Okay, so that's the dice one. Now things get a little funky if you add in a second dice, because kids will say, well, now there's 12 outcomes because it's 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10, 11, or 12. But in fact, you cannot roll a 1 because that's the smallest roll you can get, which is a 2. Okay, and some rolls are actually more likely than the others. So things get a little complicated when you add more numbers. For example, there's a 2, and that's it. I can't roll the 2 another way. I mean, I can put the dice on the side, but that's it. There's a 1 and a 1. Whereas if I take a number like 7, I could get a 4 and a 3, or I could get a 6 and a 1, or I could get a 5 and a 2. So there are more ways to get a 7 than there are to get a 2. So the outcomes change. Not all the outcomes are equal. So that's a little bit definitely more of an advanced question. Something to think about, but we're not going to examine it for this video. Let's look at, I mean, coins are the easiest, right? You know, let's say, so probability of getting tails. Well, I can get heads, I can get tails. There's only 2 possible outcomes, and the one I'm looking for is 1 out of those 2. So it's a 1 out of 2 probability, okay? 1 out of 2 likelihood, you could say. So coins are really easy, as long as they're fair. Okay, we could take a fair spinner. I got my daughter's Disney game spinner here, and this counts as a fair spinner because each space is the same size. So let's think of a little probability game here. So let's say probability of getting, let's go with let's say a clock. Let's make this one a little trickier. So on this spinner, you can see there's a 1 on the clock and there's a 2. So when you play this game, basically what happens is you're trying to beat the clock. And if you roll, or if you spin the 2, you have to add 2 hours to the clock. And then if you just get the 1, you only have to add 1 hour to the clock, okay? But anyways, the point is that there's actually, I'm now counting 2 different spots to make this a little more interesting. So how many what's my denominator going to be is how many options there are. So I could get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 equally possible outcomes on this spinner. Okay, and they're all fair, they're all evenly sized, all right? And my chance of getting a clock is not just 1, it's actually going to be 2, because there are 2 outcomes here that have the clock on them. Okay, there's the 1 clock and there's the 2 clock. So there are 2 different ways that I can get that clock, all right? So this one becomes a 2 out of 12 probability or likelihood. Now with spinners, it's important to note, like I say, let's try to make it a spinner that's not fair, that's not as obviously terrible looking. So let's make it look like that. Okay, so if you have an unfair spinner, this becomes a much more challenging question because the outcomes are no longer even. Your chance of getting, let's make this one red. Your chance of getting red is no longer just, you can't just say, oh, it's 1 out of 4 because there's 4 spots and one of them's red. Well, no, not exactly. I mean, yes, one of the 4 spaces is red, but we have an issue because these are no longer fair options, okay? It's still not bad if it's like the clock where there's 2 ways, but they're still equally sized. That's okay, right? Or if instead of a 4, let's pretend that this was a 1 as well, and there's 2 ways to get a 1. That would be okay because they're still equal spaces. So I just count the 1. In that case, I'd count the 1 twice because there'd be 2 spaces as 1s, right? But if they're not equally spaced, it becomes a whole different part of math, okay? We're no longer dealing with probability. You know, you got to bust out a protractor here and measure how many degrees the red is versus the 3, okay? Very complicated stuff, but I just want you to understand that for some games, if you see where things are not even, things are not equal, the probability becomes much more difficult to find, okay? So one of the keys to this whole thing in grade 4 and 5 is that you need to have fair things, okay? Fair spaces, fair number of sides, whatever it happens to be, it needs to be equal and fair, okay? And then you build your fraction. All right, so hopefully that's useful. Hopefully it helps you think about how different ways that we can represent those probabilities and moving off of the words. And the words are great. You know, there's nothing wrong with the words. The problem with the words is that they cover such, in some cases, such a large amount of outcomes, right? The word less likely, or the phrase less likely, covers all that area. It's a huge amount of space to cover with one term, right? There's an infinite number of fractions that exist in that space. It's humongous, right? You know, 1/3's in there, a quarter's in there, you know, 49 out of 100's in there. So there's, and then 1 out of 100's in there too. 1 out of a bazillion is in there. So there's so many fractions that are in there that it becomes very imprecise to use the term less likely or more likely. And it's better to go into something that is a fraction because then everybody understands, right? Oh, there's 6 possible outcomes and you're looking for 3 of them, right? So hopefully that's helpful and check you later.